Hi folks, this is Mrs. Sid back with you. Sorry I didn't get this video up yesterday. I had some medical stuff happen. We can talk about that a little bit more on Friday, but I apologize for getting this up late. So it's nice and early in the morning. Hopefully most of you are still sleeping at this point. So here we go. I'm going to finish the note sheet from yesterday, so this should look familiar. This was all the stuff we did in class, the parent functions. If you're having trouble with this increasing, decreasing, constant, and continuous, go back to my video from earlier this week, and that should help. So we did together in class even functions and odd functions. We did that very, very quickly at the end of class. And then I had you write down some stuff about even and odd. So let me explain this box a little bit more before we go further. So sometimes we can prove functions are even just by looking at the graph. We can see the symmetry, but sometimes we want to do it algebraically. So if we're doing this algebraically, an even function really means that whether you put in a plain old x or a negative x, you get the same output. So meaning if I were to put in 2 or negative 2, I would get the same output. Or if I were to put in 10 or negative 10, I would get the same output. But to prove it, we want to do it for the general case. So that's why we're doing it with an x. So to prove h of x is even, first we're going to do h of negative x. So if I plug in negative x here, I get negative x quantity squared plus 1. So just to think about this piece for a little bit, that's negative x times negative x. Well, negative x, so negative 1 times negative 1 is a positive 1. So this is just going to give me x squared. So this is x squared plus 1. And hey, that is the original function. So what that tells me is that h of negative x is the same thing as h of x. So whether we put in a positive or a negative input, we get the same output. So this means that this is definitely even. So check, check. Now let's do one that's odd, because the odd's a little bit funkier. So for odd, we still put in that negative x, but then we have to get out the opposite of the original. So we have to do a little more work with this. So we're going to start in the same place. It's going to feel a lot like what I just did with even, in that I'm going to put in a negative x. So I'm just substituting here. So h of negative x is 3 times negative x quantity cubed plus negative x. Okay, so let's again think about what this means. It's repeated multiplication. Negative x times negative x times negative x. Well, we know that's x squared. We just did that on the other page. Times a negative x means this is going to be negative x cubed. So I have 3 times negative x cubed plus a negative x. Right, let me clean up the way this looks. This should be a negative 3x cubed minus x. Now notice that is different than the original. The original is a positive 3x cubed plus x. So we know it's definitely not even, but then again, we're trying to prove it's odd. So what I'm going to do is take out a negative 1 from every single term. If I do that, what I see, what's left over in here, is the original function. So when we plugged in a negative x, we got the opposite of h of x. So when we plugged in negative x, we got the opposite of plain old h of x. That means that this is an odd function. So let me show you, just for some brevity, show you how this is going to work when I just say prove it's, even or odd, or there's a third choice, neither. So let's take a look at how this works. So for 1a, if I start with that negative x idea, I'm going to plug in negative x. And now I need to do some simplifying. So this is going to mean negative x to the 5th plus 3x. Well, that's definitely not the same as the original. So this step right here, that tells me that the graph or this function is not even. So I'm going to keep going and factor out that negative 1 and see if that helps. Oh, and look, what we have in parentheses is the same as the original. So that tells me that this function is odd because f of negative x equals the opposite of f of x. Whew. All right, let's try one more. And then I want to move on to some transformation work just to help some folks with that. All right, so let me do part B. So first step is I'm going to do g of negative x. I'm going to throw a negative x in here. And I get 4, well, negative x times negative x times negative x times negative x. It's basically going to just get me x to the 4th plus 5. Now, when I get to this step, I always want to go back and compare it to the original. And notice it's the same as the original. So we're going to stop here and say it's even. A function is either even or odd, and if it's or, none of the above. So a function can't be both even and odd at the same time. All right, so then neither case, by the way, none of those steps work. So I'll take a look at C. This hopefully should be kind of quick. So I start by putting in h of negative x. And I see that I get negative x minus 4. Well, that's clearly not the same as the original. So I know right there that it's not even. So then I pull out a negative 1. And what's in here is not the same as the original. So that tells me that this is also not odd. So it's not even, and it's not odd, which tells me that this falls in the case of neither. All right, I hope that helps with even and odd. Maybe our notes tomorrow I can build in some even odd work as our warm-up. These are some just quick check that if we had had time, I would have had to work on those. Good problems if you want to practice with. Okay, let's talk transformations. So looking at the homework that some folks have handed in, it looks like this is something you studied a lot last year, but we're just doing a quick refresh to make sure we're all on the same page. So vertical shifts are the shifts that go up and down. So if I have f of x plus c, this is going to move up c units. And if I have f of x minus c, this is going to go down c units. It's outside the function. It's pretty straightforward. So if I'm looking at some of my parent graphs up there, this is telling me that this is going up 3 units. So I'm going to take that parabola. Actually, I'm going to start with the vertex and just march it up 3 units. And I can take some key points and do the same. 1, 2, 3. 1, 2, 3. And then I know 2, 4 is another point. So 1, 2, 3. And there's the negative 2, 4. 1, 2, 3. So enough points for me to create my lovely parabola. As you probably have noticed, I'm not the best when it comes to drawing things, although I might be my own worst critic. So never fear about graphing things in front of me. All right, this one goes down 2. So I'm going to take key points, march it down 2. At 0.11, march it down 2. 0.42, march it down 2. Oh, there's an x-intercept. Just notice my parabola went away on that other side there. Oh. All right. Sorry about that, folks. A little glitch with OneNote here. So 1, 2, 1, 2. Back to my x-intercept here. And then 9, 3 goes down 2. So this one's kind of nice because I have both an y-intercept and an x-intercept. Kind of cool. All right. Again, for brevity, just so you're not watching a video for 30 minutes, this last one moves down 4. So again, I would just move that down 4. Let's take a look at these. So notice how the shifting is inside now. So it's inside the function. When it's inside the function, that affects x coordinates. So it's also opposite what you would think. So if I have f of x minus c, that is actually a shift. That is actually a shift of c units. Actually, I'm consistent with what I did on the last page. I should say it is right c units. So I know you see the negative and you think it's moving in the negative direction. It's actually opposite that. And then the other one is f of x plus c. That is going to move left c units. So let me show you on these graphs what that means, what that's going to look like. So say this cube root graph, number 5, I think that's what the Egyptian. This inside part here, even though it's negative, it looks like it should be moving to the left. It's actually going to move the whole graph right 1. So instead of making a table, I literally just pick up key points and march them however far I need to march them so that I can get the key points that I need on this graph in order to draw a sketch. So there I go. Let's write 1. Number 4, because it's plus 2 on the inside, it's not moving in positive directions, moving opposite that. It's kind of counterintuitive is the big word. This is going to the left 2 units. All right, so like I said, for brevity's sake, I want to keep this video kind of small so that you have time to watch it. We will definitely talk homework questions in class tomorrow, but I'm hoping that this overview of transformations and some information about even and odd functions helps you as you work on your homework. Feel free to reach out if you have any questions, and I will be with you on Friday. All right, folks.